Throughout many field campaigns, we've come a long way in expanding our knowledge and understanding of our atmosphere. But this hasn't been a one-person effort. Collaboration and close coordination within the ATTREX team have made this endeavor possible.
For any field experiment you do, you have the questions that you're trying to answer, and then you figure out which data do you need to best answer the questions. Once you've done that, then you figure out who has the capability of making those measurements.
So basically what we've done is gathered the leading experts in theory, modeling of the atmosphere, and in making these very challenging measurements.
And that's the only way that you can really do science. You have to go to the right place and measure at the right time with the right people.
And part of the reason I really like these airborne science campaigns is they're sort of these grand endeavors where everybody comes out to the field, we're all working very hard with a common goal, and very thankful to have the opportunity to get these measurements. The other thing about these NASA campaigns is the data will then be shared with everybody. So it'll be used by people from all different countries.
The more people who use the data, the more of an impact our data have.
Because we're all basically working together, trying to understand how the atmosphere works.
The data we have gathered will be used to benefit humanity for many years to come.
When you make an observation, that's only the beginning of the story. It's like walking into a crime scene and taking a picture and collecting some evidence. Footwork begins after that, the real work of putting everything together to produce a full picture of what's happening in our atmosphere.
And ATTREX is basically part of that puzzle. We're addressing a key uncertainty in how the models predict future climate change.
We have to actually figure out how all of these things work.
So the real underlying objective of ATTREX is to understand climate change. Now, it's well known that climate change will have dramatic effects on people and ecosystems across the planet.
The atmosphere is always changing. Levels of gases are changing, temperatures are changing, and you have to make very precise measurements in order to try to see those changes.
So when satellites measure, they measure basically looking through the atmosphere over a very long path length. Multiple hundreds of kilometers are averaging the data over. So if you have low water and somewhat higher water, what you're going to measure there is the average. When the airplane flies through these air masses, they're measuring over 10 and 20 meters at a time. So they're getting that entire variability.
So far, we've gathered these fine structure measurements of clouds and water vapor and the interaction between water vapor and clouds. And that's being used to better understand how the clouds form and how they affect the amount of water that's getting in the stratosphere. The other thing we've done is we've gotten a lot of measurements of these ozone-destroying substances in the tropical tropopause layer, which will ultimately get into the stratosphere, so we can better predict how much of these get into the stratosphere and again improve predictions of ozone destruction and the ozone layer recovery.
All of these processes are the things that we're after with ATTREX.
15 seconds, one pass. SA-72 is off. Right. SA-72 switches 6.
The ATTREX mission, we've seen some very, very interesting relationships between temperature, water, and particles that we're seeing in the atmosphere. This is really wonderful information and will be incredibly useful for how we can improve our modeling of the atmosphere.
But anytime you do climate science can be contentious in many parts of the world. So having data that is out there, free and open, and defendable is important. If your data aren't available for everybody, it's always going to be in question.
The way we look at it from the science community is that the data is all shared. So it'll be shared amongst different institutions and different agencies and even different countries all around the world. Because we all have the common goal of trying to understand how the atmosphere is working and how the atmosphere is changing.
The scientists' understanding of the climate system and answering the key questions that can help resolve the uncertainties that decision makers have to make. It's key.
And so we'll still need measurements, and the measurements will improve and our understanding will improve, but we'll need these measurements to further quantify how the atmosphere is changing.
The more we understand the processes, the better off society will be because of it. And some of those key processes, the only way you're going to answer them are through airborne campaigns like the one we're doing here.
Our future very much depends on the understanding of the world around us, on how this complex system we call Earth changes. That's why our mission is not only about doing research, but also about encouraging younger generations. They are the future of science and the key to continue understanding and improving the lives of all of us who call this planet home.
The students do not normally have an opportunity to see this.
To show them that there's actually stuff beyond just looking at what's in a book is very invaluable.
It gives them meaning and relevance to the work that they do in school.
I can't stress it enough just how important it is for the students to make that connection, because that's where they make their decision as to what they're going to do for the rest of their life.
It's fantastic to have real scientists, real pilots, real engineers and technicians coming in and sharing their experiences with the kids, because that brings science to life.
So we are bringing our science into their classrooms, as well as bringing the students here to see our science in action. And we're hoping that this will inspire some of the students to pursue careers in science, technology, engineering, or math, and one day maybe even work for NASA.
I saw how excited the kids were, so it's awesome.
Record the pump GDC line. Make sure power go, flight. Roger, power. S1C proof that's complete, flight. Roger, you're all good. 30 seconds. Recorded flight speed. Minus 20 seconds. Minus 20. Nice release, are you ready? Ready, 0. Minus 10. Mark. 9. Start ignition. Flame burned. Engine arm. 5, 4, 3, 2, 1. All engines running. Launch commit. That's okay, flight. All right. That's on start, flight. Next one. Hold down.
So on December 24th, 1968, astronaut William Anders took a picture of the Earth. He was in Apollo 8 and he was orbiting the moon, and he took a picture of the Earth, what's called the Earthrise picture.
Oh my God, look at that picture over there. There's the Earth coming up. Wow, that's pretty. Oh, I got it right. Oh, that's a beautiful shot.
And you look at that and the vastness of space with this gray moon, and you realize what a unique thing the Earth really is. And the Earth doesn't come with an owner's manual. It's for us to try to figure out all of the complexity that we see here.
Our campaign is coming to an end, but new ones will continue exploring, making new discoveries.
Clean release, subdues come right to north.
Our journey is not over. Keep watching. This is just the end of a new beginning.